So our next speakers are from the Boston Consulting Group. We've got, I've forgotten your name again, Bartholomew Nogash and first Clément Roche, and they're going to talk about Docker for AI and ML.
Thank you. Hello, everyone. So this is my first DockerCon, and this is actually the first time I'm doing a presentation like this. So I'm a little bit stressed out, but it's going to be OK. So today, with my colleague, Bart, we're going to talk about Docker and AI. We work for BCG Gamma as software engineers. And let me start out with maybe what is BCG Gamma? So maybe you've heard about BCG. It's a big consulting firm for strategy. We are all over the world, and we serve clients. We've been serving them for more than 40 years now. And BCG Gamma is a data science branch of BCG. We specialize in advanced analytics and AI application. Right now, we have a team of about 500 data scientists across the world. And over the past year, we started hiring software engineers and machine learning engineers to help our data scientists create and deploy our solution. And for that purpose, we also built a product, the very first BCG Gamma product. This product, we call it Source AI. Source AI is a collaborative analytics accelerator to build and deploy advanced analytics and AI solutions. So, as you can see, we come from the consulting world, so a lot of words here. But in a nutshell, it allows our data scientists to focus on what they do best, data science. Because in data science, there is a problem. All over the value chain, there are many problems from data ingestion, inconsistent quality in the data, limited compute resources when you're running data science on your laptop, on a single VM, you can hurt some hard limitation. And there is no versioning of the model, no versioning of the data. It's usually not structured to be deployed, and certainly not to be deployed into production. So with Source AI, we tried to build an end-to-end platform for AI development. We tried to automate as much as possible at every step of the value chain. So basically, we brought our software engineering knowledge to the data science world. And this translates today by a unified layer built on enterprise-grade tech, such as Docker. And now we can, for example, create infrastructure, create provision clusters with AWS and Terraform, and version the data of our data scientists using a solution like Pachyderm. And of course, run our experiments and our production model within Docker. We also run most of our services on Kubernetes. We brought to the data science world tools that are very usual for us software engineers as CI and CD pipelines. So we try to build reliability, reproducibility, and stability in our data science world. But doing this, and using Docker for AI and ML has been very challenging. And today, we would like to share with you 3 lessons we learned using Docker for AI and ML. The first one is layering for flexibility of context. So here, the problem is simple. In the data science world, you have many, many different frameworks and libraries. Every day, you have a new great framework for doing neural nets and a bunch of stuff. So it's very hard to have a single Docker file to do it all. So usually what you try to do is build one specific Docker file for every application. But when you try to build an easy and seamless platform for data science, you don't want people to build their own Docker file. And since there is no one Docker file to do it all, we had to figure out a way. And Docker has been very helpful. So this looks complicated, but it's actually a very simple idea. So we tried to break the Docker file in many different contexts, and on our platform, you can choose which data science and AI context you want to use at every level. So we start from the bottom to the top with our base OS. Nothing really complicated. You can imagine also running different OSs. Here we just have Ubuntu, but you can see a difference with system-level libraries like drivers. Hopes no one is dead. Then, a little bit more interesting, we get to the domain template. The domain template is where you choose your language of programmation, for example, Python, and you choose what is going to be the field you're going to be working on. For instance, if you do computer vision, you probably need tools and libraries to open images and encode and decode video streams. So at this level, we're going to package general use tool for your use case. We call that a domain template. So here you can start having an application, but of course you don't want to be doing data science from scratch. So we added another layer. That layer is the framework layer. And here you can choose what framework you use and what version of this framework you want to be using. So for example, if I keep my example with the computer vision, I want to build an application on computer vision. I can choose to run it on GPUs, choose my domain with computer vision, choose my TensorFlow framework, and now I can build the application I want. Based on the same image, I can run my Jupyter Notebook, for example, to figure out how my algorithm is going to be working, to try things out. When I'm happy with what I have, maybe I want to write a training application. And this is going to be based always on the same image. When my model is ready, let's build a model serving application, always based on the same image. So as you can see, we are always using the same base for many different user applications. But also if, for example, while you're building your algorithm, you figure like, maybe TensorFlow is not the right choice and you would like to use a different framework, it's very easy to switch only at that level and to build the same kind of application using a different framework. We also have a last layer of flexibility. We build our AMIs using Packer. So as you can see, we can run here, we have VMware or AWS, but we can run on different providers. And we always prepare our VM with Docker Enterprise ready. So basically, our images can run everywhere. So this flexibility was really helpful in using Docker for AI and ML, and that's why Docker is really a big enabler for us. So now I'm going to let the stage to my colleague Bart, and he's going to talk about the reproducibility of builds. Thank you.
Hear me? Okay. Another lesson that we've learned while building Source is that reproducibility is critical for production-grade machine learning models. We want to be able to run different versions of the code with different versions of data, making sure that changes in system version or libraries doesn't affect the end result. So basically there are three things that we have to version. First is the code, and this is quite simple. We are using Git. We can also enforce that there are some code reviews, that we are running some linters, some tests, using CI tool. Another thing is data. We want to be able to run different version of learning algorithm along with different version of data. For this purpose, we are using Pachyderm. Pachyderm is an application a bit similar to Git, but it's designed for data. And finally, we want to be able to reproduce the context in which the model was trained. For this purpose, we are creating a snapshot of a system with system libraries, some project-specific libraries, and the algorithm itself in Docker to use in production and training. Let's take a closer look of how we use Docker to ensure this reproducibility. We are taking the base image, which consists of some base systems, some runtime packages like Python, and also some algorithm-specific libraries. Then, on top of that, we are adding some model-specific libraries and a snapshot of the training algorithm. And like that, we are getting some training image, and we are running the experiment or learning the model on this image. As a result, we are getting some output model artifact, and then we are adding this output model artifact to the next layer of Docker, And this is how we are getting production image. Of course, we can run training with different version of data set, getting different version of production image. And having this version production image is getting simple to run this application on the client's infrastructure, because first of all, most of our clients have some Docker runtime. It can be Kubernetes, it can be Docker Swarm, it can be some cloud-specific runtime. And the second thing is that it's easier to test, because, for example, we can deploy only one container with the new version of the application and direct only some part of traffic to it. And if something went wrong, we can simply roll back to the previous version. And the last but not least lesson that we've learned while building Source is that we have to enforce collaboration policies. What does it mean? It means, for example, for code, we are using Git, we are enforcing code reviews, some test runs, but additionally, we are using Docker Trusted Registry, ACLs, to ensure that the only way to upload a new image is through continuous integration pipeline. We don't want to data scientists to push some manually made Docker images to the Docker registry, because it will be not reproducible. And of course, data scientists can still pull the image from the registry. For example, he may want to run it with some Jupyter notebook to test it out. And also, it's possible to download the image through production deployment. This is basically the system that we've built for our data scientists to use it with the client, but we are still working on it. And if you are interested to join our team to either work on the platform or support or work on AML application with a wide variety of clients, we are looking for software engineers, machine learning engineers, as well as system architects and software architects. Okay, thank you very much. That's all from us, and have a good time on the rest of DockerCon.